Hi, it's Mr. Mo on Mr. Mo Cyber Talks. Today's topic would be how to build a home DNS filtering solution using Raspberry Pi. This is not going to cost you anything apart from the cost of the Raspberry Pi, which means there's no paid software included. And in a previous video, I have taken you through how to install the Raspberry Pi OS and attach it into a network. So this is a continuation of a series of videos on home cybersecurity using Raspberry Pi. You might be wondering, why do I need a DNS filtering solution for home? In the next few slides, you will realize why. So this represents a typical home network where you might have wired and wireless clients connected to a router through a wireless access point. Most of the time, this router is provided by your ISP, which connects to the internet. Literally, most of these routers doesn't have next generation firewalling or advanced features to block, protect malware or any threats. Therefore, all your traffic just gets passed through the router. Yes, I have seen in some routers they have this content filtering, but I would question the efficacy of those. Therefore, for example, first of all, you would need to know how the DNS works. Yes, there are heaps of videos on YouTube or in Google. You can find how DNS works, but I'll quickly explain. For example, if you're in a workstation like this, and if you type www.google.com, it will initially talk to a DNS request to the configured DNS server to see what's the public IP address of www.google.com. And then the DNS server will return the public IP, and then it will establish the IP connectivity, and you will see the web page. Now, in most of the situations, the DNS server would be this router or the IP addresses of some DNS servers by your ISP. And some people use the Google public DNSs, which is 8.8.8.8. Now, there's no control in here of which websites are legitimate or which websites have a better reputation than the other in this DNS method. Therefore, you might get access to sites with malware, phishing, scamming, anything. Also, because there might be a delay in accessing these DNS servers, you might not get the best browsing performance. Number three, there are heaps of tracking software which tracks for what you're browsing, and based on that, it will uh, make sure some ads gets appeared. So these things really slows down your internet browsing experience. Plus, hackers now target DNS servers with ISPs. If they are not properly secured, they might get spoofed. So when you get www.google.com, it might return an IP address of a fake web server, which means when you go there, whatever you type could be captured by the hacker. So in order to build some trust with DNS, it's better to have that brought in internally and make it a bit secure. Right? So what I want to show here is this is a typical setup, and these are the current problems it might have. So in this slide, as I say, majority of the homes are not equipped with proper next generation firewalls. Therefore, they are prone for malware included websites, content, whatever. And most of the users are not capable of managing policies in these firewalls, even if they have any. And many users just don't know about the severity of not having a DNS blocker. So the disadvantages are the ones which I mentioned before. So the solution is, using a simple Raspberry Pi, we can install this software called Pi-hole. The Pi-hole is open source. It acts as a local DNS server for all your internal workstations. And it has a list of allowed domains. You can have custom blocks as well. So it will only allow legitimate requests out. For example, if the server wants to go to a site which doesn't have much reputation, when it makes a request for DNS in this, if it is a bad DNS, it will not return a public IP. Therefore, you will have no connection established. So that is the key. Even before a connection is established, your connection is toned down. So in the next slide, so these are the benefits. So you get more control of what is blocked or loved. And also it can block ads, the ones which slows down your internet, which is more irritating when you're browsing something, it just pops up on the side or in the middle. And mainly it works at the network DNS level. So without it blocks everything at the DNS level, so no connections are established. So the next bit will be a demo in installing Pi-hole on a Raspberry Pi and how to get it configured. I'm using containers. I know containers are new to some people. I would strongly suggest you to watch some videos on containers. However, you don't need any prior knowledge on containers in order to execute this, because I will script it out for you. So you will see the commands which I type in on a Raspberry Pi to install and get it going. And I'll have them in the description as a script, so you could copy and paste. But mainly I will show you how to get the web interface up and running so you can configure it and see the operation of it. So before I configure the Pi-hole, I want to show you how the ads appear in my existing workstation. So this website, canyoublockit.com, has got some tests like this, which will run the test and it will show you what ads appear on your workstation. If there's no ad blockers, you will see all the ads in here. There you go. See, and there's heaps of different kinds of ads. You might have seen them, but this is an ad test. So it says if you see all these things coming, and that means there's no ad blocker in place. So I'll run the same test once I install the Pi-hole and get it going. This is the installation. Most of the commands will be new to you guys, but if you are familiar with the Linux command, you will be able to understand it. But there's heaps of videos, heaps of guides available on how to install Pi-hole on a Raspberry Pi or any other Linux box. But I will copy and paste the commands which I use to configure this in the description section of this video. First of all, I will create a folder, and I've already created one, like in my home folder called Pi-hole, and in that I have, when you configure a Docker file, you need to create this image called or a file called docker-compose.yml. What it does is it will give all the parameters to create your container. Right? You create a Pi-hole container. So there's the name of the container is Pi-hole. It will grab the installation image from here, which is the latest image, and Pi-hole will be listening on TCP and UDP 53. That is where the DNS traffic is being used or listening on. All the user requests are made on UDP 53. That's why this Pi-hole will be listening on 53. And mainly these other ports are for the management portal. For example, if we are going to configure any options, we will connect to this Raspberry Pi using port 80. And this is the time zone which we are in, and this is the password. So I have blurred this out. You can, unfortunately, it stores in clear text. So that's why I have blurred it out. You can pick your own password. Don't make any changes to this because that is to run that service. Once you're done with this, that's it about the configuration. So I will just exit that, then I will also start the container. It's quite easy. The command to start the container is docker compose up -d, and once you attach that component, you can see that your container is up and running. So the command to make sure whether your Docker is running is to use the docker command. Once again, you will see that I have a few containers running, but this is one. I'm running the latest Pi-hole, and it is listening on UDP 53, 80, and 67. You see that the ports we specified in the file. So once installed, this is how it looks like when you browse on HTTP 80 into the IP address of your Raspberry Pi. In my instance, I'm running it on 192.168.5.1. So once the password for here is the password which you specified in the Docker compose file in which I showed previously. And once you enter this, you will see how the operation. I have been running this for a while now. So the whole purpose of this is I want to show you how the graph looks like. It's pretty cool. It has really blocked unwanted traffic, 71%. So I'm really using my bandwidth for real purposes. And it will show you the block domains, right? These are like tracking ads and all the malicious stuff like drugs, porn, everything will be blocked in here. And you can also get an estimate of who are the clients, from which clients I had maximum blocks and so on. So this will give you a visibility of what's really going on your home network as well. So it will provide that extra layer of visibility. So with that in mind, you can see in here uh, the add list. So with the installation, it has some configured ones, but you can do a search and find these static lists where it will find more up-to-date block lists you can include in here. Don't overload with so many because it will affect its performance, but that's pretty much it, right? And then there's you can, if you want to exclude certain domains from blocking, you can have it here and make it enable or disable. I'd say, for example, if you want to enable ads from Google, I can disable it or make it enable, whatever you like, right? So yes, you have manual control about it. Now, doing just this is not enough, because you need to point your DNS server of your workstation or the laptop to point to this. Now, how to do that is using DHCP. Most of your ISP, most of the devices in your network will be pointing to your ISP, but now you need to point it to the your Raspberry Pi's IP. So I am using a Meraki device as my home gateway. So in here, in my DHCP setting, I'm saying my name servers as 5.1. Right? And once it's done, I'll come back and I'll do a ipconfig, release, and a renew. So to make sure that my DNS servers have been updated. Right? So I can do that. I can do a NS lookup and see what's coming up. Looks like it hasn't updated. All right, so my DNS has been updated. So you can see it's trying to resolve against the Raspberry Pi, which I configured with Pi-hole. So this is my configured. Now, in order to prove certain stuff, I'll show you using the same website which I checked on ad blocking. So let's run the test all over again and see what happens with the pi-hole configuration. So now this should block all the ads in here. So there you go. So it has detected an ad blocker, right? And in the previous example, you saw that there were ads appearing here. So my ad blocking have worked. Watch more videos like this. Feel free to subscribe to my channel. Thank you.